Hello children, welcome to channel Sube. Children, today I am going to discuss question number 21 from the MCQ part of 2022-23 Physics New Syllabus paper. Consider the following statements made regarding tsunami waves. Capital A. Wavelengths of waves in deep water are lower than that in shallow water. Capital B. Speeds of waves are higher in deep water than that in shallow water. Capital C. Amplitudes of the waves in deep water are higher than that in shallow water. Of the above statements, first one, only A is true, only B is true, only A and C are true, only B and C are true, all A, B and C are true. So children, to answer this question, you should remember there is a diagram and also there are two equations. So if you know those, you can answer this easily. So let us first draw the diagram. So this one is the sea, then this one is the land, so this one is the seabed, so like this. Yeah. So like this. So due to some reasons, what are the reasons? A tsunami is a series of enormous waves created by an underwater disturbance, usually associated with earthquakes occurring below or near the ocean, and also volcanic eruptions, submarine landslides and coastal rockfalls can also generate a tsunami, as can a large asteroid impacting the ocean also can generate a tsunami. So due to those reasons, what happens? There will be a huge peak like this, water peak. The water jumps out like this and make a peak like this. So it has energy. It has energy from that earthquake or the explosion, or from the particle that dropped down to the sea. So this volume you have to get into account. This volume, this total volume has a certain energy absorbed from that incident. So then this hill of water can't stay like this, because it goes to the lowest energy level. That means it falls down like this. It falls, but it oscillates again. What happens? That energy goes to another heap of water like this. So like that it moves at a velocity, at a certain velocity. So at first the hill, the peak is the wavelength is larger. Wavelength is larger like this. So we can calibrate like this. The wavelength decreases while it is moving towards the beach. So like this, the lambda decreases. Lambda decreases. So the wave will be like this. Little by little, its amplitude increases. So it is like this. Like this. So this one is the wavelength. From here to here, it is the wavelength. So suppose this is the depth. This one is the depth or height from the sea bottom to the water level. Normally we say depth. So the equation between the relationship between this lambda and h is equals to root g times h. So at the deeper places, the lambda is higher. So when we go deep, when the sea is deep, the lambda is higher. So when we go deeper, at deeper places, the lambda is higher according to this equation. This equation we learn when we learn ripple tank. So in the laboratory there is a tank made of glass to study the properties of mechanical waves. So there is a frame for this tank, and we fill water. You might have done it. Half of it, half of the tank we fill water, and there are legs to keep this erect like this on the cement floor, and there is a vibrator here. We fix it using then we supply current, then it vibrates. So there will be waves like this, lot of waves. So we can wave fronts. So we light up a bulb above to this tank, and we can see the images of these waves like this under the tank on the cement floor. Or we can place a screen, white paper, something like that, or a black paper, something like that. According to the light level we have to decide it. So we can measure even the wavelength lambda even here. So like that we learn this about this ripple tank. So at that time we learn normally this equation. So according to this equation, the relationship you can see easily. So here, since at far away from the shore, from the beach, the deeper places, the lambda wavelength is higher or larger or longer. Wavelength is longer. So wavelengths of waves in deep water are lower than in shallow water. They say deep water lower. It is wrong. At deep water it is higher, not lower, it is greater. So this one, according to that, this statement is wrong. They say, so what we say according to the logic of this equation, at deeper places lambda is higher. But what they say, in deep water lower wavelengths are lower. So it is wrong. Shorter. It should be shorter, no, not lower. So it doesn't matter. This is not English, so this is physics. Then it doesn't matter. So however we get the idea. So it is wrong, therefore. Speed. So now let us go to speed. So there is another equation that you know, V equals f lambda. So when lambda increase, lambda is higher, lambda is longer at deeper places, what happens? So this V also higher, V also higher, because F is constant, because the source is the same. Source is that explosion or something like that, or the earthquake, or the thing that is fallen into this sea. So the source is that. So therefore frequency doesn't change. Frequency is constant. So V is higher at deeper places. At deeper places, velocity is higher. What they say, speeds of waves are higher in deep water, and that is correct. Higher in deep water, they say the same thing what we say, higher in deep water than that in shallow water. Here shallow water, so that one is correct, isn't it? It is correct. So then amplitude, amplitude is, what is the amplitude? Amplitude is the height above this level, above this normal level. This height is called amplitude, height to the peak of this wave from the center level. So the energy of this wave is there in this volume of water. The energy is absorbed by this amount of water. So it is constant. Little by little it decreases, but almost it is constant until it reaches this beach. So the wave, what happens to the wavelength decreases while it is coming towards the ground, towards the land side. So this base, this length of this basin, this area of this base is little by little decreasing. You can see the base area is decreasing. Therefore, for the volume to be constant like this, the area from top is added. The area is taken from this upper part, because the area at down part is decreasing like this. Area of the wave, the down part is decreasing because lambda is decreasing. Therefore, to keep the volume of this amount of water which has the energy, it takes from top like this. Top increases because the lower part is decreasing. Therefore, to keep the volume constant, it catches area from area or volume, actually volume from upper side. So therefore the height increases like this while it is coming towards the land side. So that is what is happening. So therefore what happens to this height means capital A, that means amplitude. We normally don't say the height of a wave, that is what we call using this word amplitude. So amplitude increases, so height of the wave increases, because as I explained, the bottom area is decreasing somehow to keep this volume constant. Volume should be equal to this volume, the initial volume. The volume, to keep the volume constant, it catches volume from this upper side like this. Upper side. Then all the volumes are equal. Here all the volumes are equal like this. Not exactly, not accurately, roughly the volumes must be equal, because energy is conserved. Therefore, according to the conservation of energy, the law of conservation of energy. So that should be happen like that. Therefore, the amplitude at deeper places is lower. At deeper places, amplitude is lower at deeper places. At shallow places the amplitude is higher. But they say amplitude of the waves in deep water are higher. No, it is not higher. Here it is higher. At deep water, I have drawn in red color. You can see this height is lower at deep. In deep water are higher, they say. It is wrong. In deep water it is not higher, it is lower. At shallow water it is higher, that is correct, than that in shallow. So this one also then wrong. Only B is correct. So only B is true. So this one is the answer. So let us check the answer sheet. Question number 21, 2021. The second one is the answer. Second one. So that is how it should be explained, as I said. So I think you can understand, and I think you are happy according to the way I explained it. I did it taking very little time, without stretching this, without elasticking, as if it is elastic. So children, I think you are happy. So if you are happy, you have to subscribe my channel and make me happy too. If you haven't if you haven't yet subscribed my channel, then please subscribe my channel and give me a help to improve my channel, and also share my link among your friends so that I gain my audience, and also press the thumb up icon and give me a like. Then only this video is going to be spread by the YouTube. And also you can press the bell icon so that you can get the message as soon as I uploaded the video. So children, see you tomorrow in the evening around 6 o'clock. Goodbye, so long.